Hello everyone. Welcome back to Dr. Liu's VCE Physics channel. Today, let's learn together about the 2019 VCE Physics examination. We will focus on questions related to light as a particle. My explanations may not be perfect. If any teachers, parents, or students find errors, please feel free to provide your guidance. We calculate the de Broglie wavelength of these electrons with the equation of de Broglie wavelength. The units of Planck's constant are joule seconds because the units of speed and mass are kilograms and meters per second. Electrons' wavelength is inversely proportional to their speed. When the speed increases, the wavelength decreases. Since the width of the diffraction pattern is proportional to wavelength, fringe spacing will decrease if wavelength decreases. To explain the photoelectric effect, we must consider light as photons. The energy of the photo is proportional to frequency, not intensity. However, higher intensity, more photons, and larger current. So, D is correct. Laser light is coherent, and incandescent light is incoherent. Students are studying the photoelectric effect. Planck's constant is the slope of this line. Rise divided by run is slope. Here, the units of Planck's constant are EVS. When the light with the lowest frequency shines on the surface of metal, the kinetic energy of electrons is zero. The lowest frequency of light has the maximum wavelength of light. We calculate this maximum wavelength by the equation about speed, frequency, and wavelength. Please convert the units into nanometers. The work function is the y-intercept of this line. If the work function is halved, the solid line will be moved parallelly right to half y-intercept. Moving electrons exhibit a wave property. As diffraction is dependent on wavelength, if the de Broglie wavelength of the electron is the same as the wavelength of the X-ray, then the diffraction patterns will be the same. We know the kinetic energy of electrons. The speed of electrons is solved from the kinetic energy equation, and the momentum is expressed as speed. Substituting the value of kinetic energy into the equation, we calculate the momentum. Since the electrons act as a de Broglie wave, we calculate the wavelength of electrons. The wavelength of electrons will be the same as that of X-rays because its diffraction pattern is the same as the electrons. The speed of X-rays is the speed of light. Finally, we calculate the frequency. Explain how the hydrogen atom could be excited to the n=4 state in one step. The hydrogen atom must absorb 12.8 eV of energy from an incident photon or electron. The absorb and exact number of energy are keywords. When the electrons jump down from a high energy level to the lower level, the photo should be emitted. The energy of these photons is equal to gaps between energy levels. There are three pathways from the fourth level to the secondary level: 4 to 2, 4 to 3, and 3 to 2. In light as a particle, 4 multiple-choice questions are worth 4 marks, and 3 short-answer questions are worth 18 marks. The overall score for this section is 22 marks. With a total possible score of 130 points, the percentage for this section is 16.9% of the total score. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.